Okay, let's discuss some terminologies used in wave. Is that okay? So let's go. The first one I want to consider is a cycle. How do I even define a cycle for you? What do you have there? And you talk. It doesn't interfere with the video. You can. Do you get it? Alright. So a cycle is a complete revolution. A cycle is a complete revolution or complete to and fro movement. To and fro movement of the vibrating particle. Of the vibrating particle. So that's what we call a cycle. Is that clear? Then number two. So when you hear the wave has traveled a cycle, that's what we mean. So for example, this is a cycle. If this thing was oscillating back, forth, like this, right? This would be a cycle. It starts from here. 1, 2, you get that? 3. That is what? A cycle. So those were 3 cycles you saw, right? Alright, back and forth movement. So the next one is amplitude. Let's discuss amplitude. Amplitude is the maximum upward or downward displacement. Amplitude is what? Maximum upward or downward displacement of the particle. Okay, so maximum upward or downward displacement. It is measured in meters. Does that make sense? It's measured in meters. So consider this wave below. Let's calculate the amplitude. Look at this wave. Make sure you're following me. Look at this wave. Now, you see that the maximum upward is, so this place is called its amplitude. This is amplitude. First, let's describe this wave. We know that this top will be called what? Crest. This is what we will call what? Trough. The top will call what? Bottom. Trough. So the maximum upward or downward displacement, that's what we call amplitude. So if I said this wave here, that the amplitude was 4, this place here, I give you -4 because it's in negative direction. The amplitude of this wave is going to be 4 meters. Do you understand? Provided that this one is measured in meters, is written in meters. Is it clear? Make sure you put it down. But a second, yes, put it down. A second type of wave that you can see, wherein you be given to calculate amplitude, is one in which, see, amplitude means your maximum displacement away from the minimum displacement. This is the point of minimum displacement or point in which there is no movement at all. This point of this line here, this is the midpoint. Is that okay? Or point of minimum displacement. So your point of maximum displacement away from that 0 point, whether it's to the top or to the bottom. That's what you call what? Amplitude. Amplitude has some effects on, for example, sound. So if you increase the amplitude of sound, what you increase is the volume of the sound. Yes, sir. The increment in the amplitude of sound is increment in the volume of the sound. So that's one of the effects. So for example, look at this wave now. Just one passion. Now look at this. You notice that this top here is more than this bottom, right? Remember I said here, you just pick whether from here to here 4 or from here to here 4 because it is regular. But for this kind of wave, it means that this thing has been adjusted. So this is not its point of minimum displacement. This line here, I said that line is the point of minimum displacement, or points where there's no displacement. It's not going up, it's not going down. It's just there. That is on that line. Now, this wave is not, this line you're seeing is not its own point of minimum displacement. Why? Because you see the maximum displacement upward is so much or high compared to this guy. So what you do, you raise this guy. But if you were given, for example, you were given this place A, you were given this place minus B, and you're told to find the amplitude of this wave, what you do is you take A minus B, you subtract them, divided by 2. This will become A plus B over 2. Does that make sense to you? Let's use that formula here. Take this one, 4 minus 4 over 2. What does that become? 4 plus 4 over 2. That is what? 4. 8 over 2, which is still 4. Do you get it now? So whether we pick one, we just solve, we get the same answer. But in case like this, it's very useful to understand this. Do you get it? So if this one was given to be 10, for example, and it was given to be minus 2, what would be the amplitude of the wave? That would be 10 minus 2 all over 2. Is that okay? You subtract this upward and downward displacement, you subtract them, and you take the average. Is that okay? That will become 10 plus 2 over 2, which is equal to 6. Is this clear? I put it down. Let's go to the next one. Just one passion, one purpose. Alright. So the next terminology that I want to discuss is the period. Is what? The period. Alright. Period is the time taken to complete a revolution, or a cycle, or a wavelength. So those are the 3 terms that I want to use for it. Is that okay? Time taken to complete a revolution, or a cycle, or a wavelength. Because cycle there refers to revolution, revolution there also refers to wavelength. A wavelength is a complete cycle. Let me show you what a wavelength is. A wavelength is a complete cycle. When can we make a circle out of this thing? See, this is one part of the circle. If I take this, cut this other part, I come and put it here. If I now make the circle, so the cycle is from here to here. And if I think of it, I say it's going up and down 1, up, down 1, up, down 2. Do you get it? Alright. So that's what the cycle is. So it's a period that it takes the wave to complete a circle. Period is the time that it takes the wave to complete a cycle. Good. So, and I've showed you how to look at the circle, right? So how many cycles are inside this wave, for example? How many cycles? 2. How many cycles are here? Let's see. 1, right? 2, right? 2.5. It's not 2, it's what? Right. So give me this now. Let me show you an example. If I said you should now calculate the period of this wave. Let's say a wave was graphed like this. And at this point, you're given 8 seconds. That is, it took 8 seconds to get to this point. And then the question answered, find period. Period is denoted by T or capital P. But in our convention, In Nigeria, we usually use T most of the time. Is that okay? So find period. Do you know what to do? What did we say period was? Time taken to complete a revolution. That is time per number of revolution. That's with the formula mathematically. Is that okay? Period of what? Time per number of revolution. Period is not equal to time. Is that okay? Period is the time per revolution. Time could be the time taken to complete the entire journey of the wave. That could be time. The period is time per revolution. So look at how many revolutions are in that first one. Is that okay? So our period is going to be time. What's the time? 8 seconds over. What's the number of revolutions we have? Let's see. One. Don't say three, Abby. You must know it all. 1, 2, 3, and half. Because for this one to complete the revolution, it needs this part, but it's not there, right? It's what? 3.5 revolution. So you now come in. 3.5 revolution means 7/2 rev, right? You now come in 7/2 revolution. So this becomes 8 times 2/7. Do that. 16 divided by 7. 285. Okay? So this will be in seconds. This will be the period taken to complete one cycle. This will be the what? Alright. Find this for me. Give me the period if the time taken to get here was 10 seconds. Find the period for me. Let's go. So the question says that you are given a waveform like this. This is called a waveform. You are given a waveform like this. And it says the time taken to get here is 10 seconds. What will be the period? Calculate period or find T. So if you are told to calculate period, it means you are told to calculate the time it will take to complete one revolution. The second revolution. Do you understand? One revolution, only one revolution. So let's go. If this is, let's go. How many revolutions do we have? 1 and 2 revs. Isn't it? If it is 1 rev and 2 rev, and this is 10 seconds, it means this is what? 5 seconds. You don't need to calculate. You don't need to calculate. The answer is 5 seconds. But you still want to calculate. You simply say that. Anyways, look here. We know that the time is what? 10 seconds over the number of revolutions. How many revolutions do we see there? How many revs? 2. A1, A5. What did you not do to get for? What did you do to get for? Okay, let's take it. Let's take it now. Should I give it now? Is it clear? Should we go to the next one? Are you sure it's clear? Make sure you tell me if it's not clear. Eh? It's not 2.5. It's 2. 1, 2. You get it, that's a circle. Now give me, okay, it is measured in seconds. Have you seen that? Period is measured in what? Seconds, like the unit of time. It's measured in seconds. Then, are you with me? So let's go to the next. Okay. Period is also defined. as the per unit of frequency. It's also defined as what? Per unit of frequency. Now see, I've written this formula. Time over number. So that is the second formula. Per unit of frequency means period is equal to 1 over f. First is equal to what? 1 over f. So let's go to f now. So I will know what f is. Alright, frequency. The next one is number 4. We said what? Frequency. This is defined as the number of revolutions per second. The number of revolutions per second. This is the number of revolutions per second. It is measured in hertz. Frequency. Hertz. Is measured in hertz. Recall that T is equal to 1 over f, right? By the time you cross multiply, you have Tf is equal to 1, right? If I was asked by T, what do you have? F is equal to 1 over T. Does that make sense? So it means that hertz has a second unit. That will be 1 over seconds. So we call it hertz is equal to hertz or per second. Hertz is the same as what? Per second. So now I tell you this. Look at the wave here. This wave, I tell you the seconds is 10 seconds. The time for the entire wave is 10 seconds. So what you first do is get the period. How do you get the period? Number of revolutions. How many revolutions do we have? 1, 2.5. Right? So that's so this is all you do. Let's find the period. How do you find the period? Period T, you said is number of time over number of waves. So what's the time here? That time 10 seconds over 2.5 revolutions. So that becomes 10 over 5 over 2. This one will work. That will be 10 times 2 over 5 here 1. Here 1, 5 here 2, 5 2 times. That's 4. Is that okay? 4 seconds for what? Period. But frequency is now 1 over T. Is that okay? So that will now say that F will equal to 1 over 4, which is equal to 0.25 hertz or per second. Is it clear? You may write hertz alone. Is that okay? You may write hertz alone. Alright. Alright, let's go. Number 5. Give me velocity. 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 This is the time rate of displacement of the particle. This is the time rate of this displacement of the particle. This is the time rate of displacement of the particle. Hmm? Velocity is what? Time rate of illumination. It is given by the product of frequency times lambda. Okay, we haven't talked about lambda. This is the formula for wavelength. So you know what you do? Leave space and let's go talk about wavelength. If this is the distance, wavelength is denoted by this lambda. This guy is denoted by small v. Frequency is denoted by small f. Is that okay? The only period that has capital D. Are you with me? And what have you decided was is the distance between two successive or two consecutive troughs or crests. Is the distance two successive or consecutive. Just pick anyone. Yes. So let me show you the definition. What the definition means. The definition it uses is very okay. Okay. That definition is just useful. Is that okay? So the distance between any two successive crests. This is the first crest. When is the second crest? Here, right? The distance between them is called lambda. So if it's trough too, distance between two successive crests and trough, from here to here you have another lambda. Do you get it? Right. It is also defined as the distance between it is also defined as the distance between three antinodes or three nodes. It's also defined as the distance between three antinodes or three nodes in a stationary wave. Alright. So now we know wavelength, right? So but the way to view it is just look at the circle. And it makes sense, even here. It makes sense. See, look at this. From here to here will be 1 over 4, right? So from here to here to be 1 over 4. So 1 over 4 plus 1 over 4, that's what? 1 over 2 plus another 1 over 2. The distance between two successive crests and waves. Plus. So you look at this shape like this. This here, right? Eh? If I cut this and I have my arm, I cut this and I have my arm. By the time I join them on opposite side, you know to form the complete circle. Do you believe that? So that's why it's also correct to say it is the distance between two successive crests and two successive troughs. Are you with me? Right. It is measured in meters. Wavelength is what? Look at what we used to denote it. Okay, are you with me? Let's go. Velocity. We define velocity. Eh? It is given by V, the product of, it is given by the product of frequency and diligence. It is given by the product of frequency and wavelength. Exactly. Alright. You also recall that someone said F was equal to 1 over T, right? If that person is true, then V should be equal to F, and that's what I said. And you should be able to answer any question that is associated with this. Is that okay? But we said that F is 1 over T, and F is now, so we'll now take this 1 over T, we use to replace F. Is that okay? That becomes V equal to what? Lambda over T. You understand? It becomes lambda over T. Alright. Let's go to which other thing? Give me phase. Phase like this. PHASE. No, no. Okay, yes. Number 7. Because that's number 6, right? That'll be number 7. Hmm? What did we say? Okay, give me phase. When two particles are said or 2 points on a wave. When two particles or 2 points on a wave. When two particles or 2 points on a wave have the same, we said that if two sides of the wave are said to be in phase, it means they have the same, it means they have the same maximum displacement from the minimum point of displacement. Is it clear? Right. So minimum deviation. When 2 points are said to be in phase, it means they have the same distance from the minimum deviation. And they are said to be out of phase if they have different distance from the different distance from the minimum point of displacement. So let's consider this wave, right? Come on. I said they are said to be in phase and out of phase, right? Okay. So first, let's assume that from here to here to from here to here. Is that okay? So we said, give me the points on this wave that are in phase. And I label A, B, C, D, E, F, G, H, I, J, K. Now, which 2 points are in phase here? The points that have the same displacement from the minimum, right? Right? So B here is on this side that is rising. I look for which side that is rising on this side. So B and H are in phase. Where is it? You get this? If you check that they are in the same side, for example, B and H are in phase. B and H are in what? Go look at it. This is a complete this thing, oscillation. So the next thing is for this thing to climb. So for it to climb to this point, it is also what? Going to have the same attribute as A. Are you with me? The next one, D will be in phase with who? Exactly. You understand now? Alright. So now write phase difference. This is where we'll stop terminologies. Phase difference. Under phase now, phase difference. Consider these two waves. This is what we want to analyze. This is where this thing becomes problematic. I want to analyze, I want to see how much they are out of phase by 2 points. So let's say for example I take point A and point D. So we say that let's see how much